Am I good? Oh, perfect. All right, hello everybody, and welcome. Hello. My name is Will Stewart. I am the Data Center Segment Manager for HARTIng. HARTIng is a leading supplier of connectors and cable assemblies, and I'm here today to talk to you about how connectors can help increase uptime in data centers. Now, one of the things that people usually, like the way people usually employ connectors is it is the last thing that they think about in their system, where they have a black box that has some sort of electrical or network requirements, and then there's some other system that needs to pass that electricity or communicate it with it in some way, and you design both of those systems, and the last thing that you do is you figure out what type of connector can pass those signals, and you try to find the cheapest one as possible. That's what people normally do, but what I'm here to tell you today is that there's three benefits. I'm going to talk to you about two of them, but there's three main benefits that you can get by thinking about the connector at the beginning of the design process. And the first is faster install time. You can bring your data centers online faster, which we argue increases your uptime and starts you generating revenue sooner, decreasing the critical path to installation. The second is you can reduce the footprint, reduce the size of your equipment, increasing density, and being able to have more revenue generating assets inside of your data center. The third is sustainability. I have limited time up here, so I'm not going to get into it too much, but I'll give a couple of shout outs halfway through the presentation. So right now I want to give you examples of how we are able to get that done. The first is through power whips. I'm talking about faster install time. And the first one I want to talk to you about is Microsoft Project Olympus. So Microsoft announced Project Olympus here at the OCP Summit back in 2016. And the thing that is relevant for us is that they use a HARTIng connector to separate the rack PDU from the input cable assembly. Now, this is surprising to a lot of people because you will never actually disconnect that connector in operation at the data center. So why would you use it in the application? And the reason why is because these PDUs that Microsoft was using were being deployed all over the world. So there was a bunch of different SKUs that they needed. It required like different amperages. It required different like regulatory certifications, right? Like UL, CSA, IEC, et cetera. It required different plugs, right? Connectors that connected to the facility side. And so it was just a very complex supply chain web. At the same time, it also was very high lead time item. It took a long time to actually get them manufactured, especially at the quantities that they wanted. And it just wasn't really a perfect, very easy like supply chain solution to be able to deploy. What Microsoft figured out with HARTIng's help is that these were two separate problems. The issue of complexity was always tied up in the cable, right? The amperages just depended on the wire size. The regulations, right? UL, CSA, et cetera, that was all inside of the cable. The facility plug, again, only applied to the cable. But then it was the rack PDU itself that was the high lead time item. So by separating the cable from the rack PDU, they were able to create a universal rack PDU that can be used anywhere in the world. And then with that, right, now you can hold inventory of it. Now your means of production go up, so the costs come down. And the complex side of it with the cable assembly was those could be manufactured by themselves. So putting that all together, they were able to separate the power whip from the rack PDU. It created a universal rack PDU. They were able to reduce their lead time for this by 75%, 8 weeks to 2 weeks. Again, shortening the time to install, bringing them online faster, and overall it just simplified their supply chain and optimized the inventory. And of course, because this is the Open Compute project, ORV3 saw what Microsoft did with Project Olympus, and they said, hey, that's pretty cool, let's do that too. So they employed the Project Olympus configuration. I'm not going to get too big into the specifications, but essentially it's a 7-wire contact that allows this kind of whole thing to work. So the ORV3 input power connector for the power shelf has the exact same contact configuration, creating a universal power shelf, reducing lead times, and also this allows you to, gives you the potential for reusing the power cables for sustainability. Again, this is kind of the sustainability thing, but I won't go too much into it. Now, HARTIng does supply these cable assemblies, so this is going to be my one slide where I'm just pushing this a little bit just because it's a new product and we're very excited about it. So some reasons why we think we're a very good supplier for these cable assemblies. Number one, we've been doing this a lot. We already supplied this for hyperscale operators and have been doing it very successfully since 2016. We think we're a very well trusted cable assembly supplier. Number two is the improved jumper design. So I talked a little bit about how there's 7 contacts, but this is a 5-wire cable. So you have to go from 5 wires to 7 contacts. We've learned that splicing internally is very hands-on and just takes a long time for labor. So what we've actually created a bridge. It's essentially a bus bar in between the contacts, which allows a smaller assembly time and fewer mistakes. We're very proud of that. And finally, we do all this production in our Silao, Mexico manufacturing plant, which is great for the North American market. We've seen across industries that everybody's really trying to reshore and manufacture local to the region that it's being deployed in, and we're very happy to support that for data centers and other industries in our Silao, Mexico plant. All right, so that was my one sales thing. Now I'm only going to focus on applications from here on out. So another way that we bring data centers online faster is through lighting. So if you go into a data center and look up, you'll see that there is lights everywhere, right? And those lights have conduits and junction boxes. And if you opened up those junction boxes, it would be, loose wires that are screwed together by a screw nut. And again, this is just kind of the way people have always done it. Here you can see on the slide that that's where you would find the junction boxes. Almost always these are wired by hands, and almost always these require additional technicians to come in and do the wiring. Or if you don't get those technicians, then it takes a longer time. So we see this, and we see how it's going to extend the time for installation again, right? You're not going to be able to install your racks, your power, anything until you have the lights on, right? So if you want to shorten the critical path, there's ways, the critical path to installation and uptime, there's ways to be able to speed this up. And lighting is a great example of it. We have applications in the field. We're using some of our connectors in order to connect the power and sometimes signal, depending on the illumination management system, to be able to get online faster. Eliminates the hand wiring, reduces the amount of labor that you need, and reduces time to market. In most of my other applications, I will give you an example of the percentages that we have found in our projects. For this one, I wasn't able to be very confident about it, but I think it reduces labor by about 25%. Obviously, 100% of the wiring time, or let's say 90% of the wiring time goes away. But when you include the installation of the lights and things like that, you save about 25% with a connectorized solution. The next application I want to talk about is building management systems. Again, getting the data center online faster. The BMS can be comprised of a lot of systems. The one I want to talk about today is the air handling unit, just as an example. So typically you have your air handling system, your crack or craw, whatever, and that is comprised of a bunch of equipment, right? Like fans that have VFDs, or cooled water coils, or dampers, things like that. And those all need to be controlled typically by a PLC. So therefore, you have a control unit that's controlling what's in the field, and very typically these are wired by hand. Where if it's a VFD, right, you wire into the VFD, and then you bring the wire all the way back, open up the PLC cabinet, and land it inside of the control cabinet. I actually did this for 5 years working for Rockwell Automation, so it brings back a lot of not so great memories for me. It's a very arduous process, I would say. It's really prone to wiring errors. And again, you can't turn your data center on until this gets installed. So if you want to get your data center online faster, this could be a way to shortening your critical path. And what we have found is that taking away the hand wiring and replacing it by control signals like M12, M17, M23s, depending on your system, you can get we have cases where there's a 30% cost savings with a connectorized solution. Obviously, the M12 is going to have a little bit more of a capital expense than just the flat wires. But if you look at the labor that you can save, it came out to 30%. Another benefit is the cabinet is completely pre-wired, so all of that gets figured out in the production line, which is normally a more cost-effective labor than doing it in the field, and eliminates wiring because or wiring failures because you'll be able to test it in the lab. So there's really a lot of benefits to it. I'm pretty happy about it. So those are some examples for faster install time. Now I want to look at the reduced footprint. So one connector that you see kind of everywhere is the IEC 60309 connector. You can see one here as an example. And IEC 60309, it's a great connector for a lot of reasons. It's a very standardized connector. Everybody is kind of really familiar with it. It's widely stocked, right? It's always available in distribution. But it's also a connector that it's used in like ship-to-shore applications, right? And a lot of like power generation applications. It is very like water resistant and vibration proof. And these things don't really, these problems don't exist in data centers, right? Having the water, having the vibration. And so we think our connector matches up great with it, and we have been using it in applications where there is a power cabinet that has many like connectors coming off of it. You can fit almost twice as many HARTING connectors as you can compared to an IEC 60309. So we're significantly smaller, we're less expensive, we have higher power ratings. Not higher power ratings, but more, right? There's only really 3 power levels for an IEC 60309. But with a HARTING connector, we have a modular series to be able to get you exactly what you need. And it's future-proof because you can keep the same exterior of the connector, right, what we call the housing, and be able to change the internals depending on what your powers are. Next thing I want to look at is RJ45. So I like to say that it's funny because RJ45 is one of the most like abundant connectors in the world, and it's probably the worst designed connector in the world. It is way too big for what it needs to do. It's just a very large connector. And the plastic clip that holds it all together is one of the worst locking mechanisms you could ever conceive for a connector. So naturally, it's what's being used everywhere. We actually are in a partnership to, so there's about 3 manufacturers for this IX Industrial. It does use the same, communication as the RJ45, so you can actually hook up the IX Industrial on the same cable as an RJ45, but it's 70% smaller as a connector. And this is 70% face-to-face. On the PCB itself, it's about 50% smaller. So on a given PCB, you can fit twice as many connections with the IX Industrial. At the same time, it's a lot more robust. It doesn't have that very flimsy plastic tab. And you have 10 gigabit speed and Cat6a. Really, I'm not sure if this is going to be as good for like things like patch panels and things like that, just because the size of the cables coming out. If you double the number of connections, you double the size of the cables coming out. But for things like aux cables, for things like auxiliary, maybe even like for example on a rack PDU, if you want to put a couple of the Ethernet ports on there, IX Industrial is it's a great option for that. And again, reduces the footprint. Another example I want to give is going back to the BMS cabinets. So I talked before about putting M12s on it in order to get to market faster. Another component of the PLC cabinet I want to talk about is the fuse terminal block that you can see up there. So if you have a PLC, I mean, it's required to either have a fuse or a circuit breaker, something that can protect the PLC, because PLCs cost, I mean, tens of thousands of dollars. Whereas a fuse costs $1. And one of the things, actually an application that we have, is to kind of improve this system, because if you look at like the percentage of the cabinet that fuse terminal block is, I mean maybe 10%, it's kind of significant. And it requires you to go in the cabinet in order to replace the fuse, which means you need the labor, you need the right skill available in order to go in. And what we have produced with one of our co-location partners is actually an M12 connector that incorporates the fuse. So you can take the fuse out of the cabinet and use it on that M12 on the side, which is especially perfect if you're already incorporating the M12 that I talked about before. get online 30% faster, or have 30% cost savings with that use case. So with this fuse connector, now we have a 50% reduction in install time. Again, another 30% overall cost savings, and a 15% reduction in sheet metal because they can make the PLC cabinet smaller. So very, very cool solution. It's something that we're actually it's in pre-production right now, and we're kind of, again, selling them to that one customer. But we're going to launch fully here in the next month or two. This is a really cool solution. We call it the Han Protect. It's very nice. Oh, and another thing is it also has that light. I don't have a great picture of it, but that red light lights up when the fuse is blown. So you can actually see from the outside if your cabinet's not working and your PLC is giving you an alarm or something like that. You can see externally that the fuse has been blown, and you can replace it very easy with whatever labor is available. All right, so putting that all together, I've talked about a couple of different applications, right, for power distribution inside of building management, in networking, for how us working with our customers talking about connectivity has had a variety of benefits, specifically faster installation time and reduced footprint. And if you start working with a connector company, you are able to find ways to do this as well. We're very, very proud of this. The last thing I just want to say is that we're actually hosting an event at the Haberdasher tonight from 6:30 to 9:30, which is it's a speakeasy, and it is going to be a whiskey tasting, and then we're going to have an open bar and snacks. Should be a great time. I think we do have a few spots still available, so if you're interested in that, please come up to me, and I'll be happy to give you more information. All right, thank you everybody for your attention, and have a great summit.